Hello, I'm a high school senior who took AP-CSA last year and scored a 5. This is going to be a series of videos where I go through the new AP-CSA curriculum to help you through the class and eventually the exam. I wanted to do this for mainly two reasons. First, with the updated curriculum, all of the videos made for this course previously are now outdated. And second, all of these videos I feel miss the authenticity I hope to provide from being an actual student who took the exam. Without further ado, let's go. First is Unit 1, using objects and methods, making up 15 to 25% of the exam. And in this video, we're going to be covering topic 1.5, casting and range of variables. The casting operators parentheses int and parentheses double can be used to convert from a double value to an int value, or vice versa. Let's say we have an integer variable x that holds 5. Maybe we want to print the variable x, but we want it to be a double when it is output. We do this by casting x to a double, as so. And of course, the opposite can be done as well. You can also use the casting operators on the numbers themselves. It's not limited to just the variables. Casting a double value to an int value causes the digits to the right of the decimal point to be truncated. A very common mistake is to assume that casting int to a double will round the value. Do not fall for such tricks. No matter what comes after the decimal place, it will be truncated. Some code causes int values to be automatically cast to double values. Let's go back to our x variable and say we want to create a double variable y that holds the value of x multiplied by 2. Because y was declared as a double, it is going to hold the value of 10.0, even though evaluation rules say it should be the integer 10. This is called widening. Values of type double can be rounded to the nearest integer by casting the value of x plus 0.5 to int for non-negative numbers, or by casting the value of x minus 0.5 to int for negative numbers. This is the first of many quote-unquote tips and tricks that are included in the course. These are small things College Board wants you to have memorized that will be included as part of a problem. There will be no explanation, it is just understood that you know what it's doing. So, know what it's doing. The constant integer.maxValue holds the value of the largest possible int value. The constant integer.minValue holds the value of the smallest possible int value. The largest maximum integer you can have is around 2 billion, and the smallest is around negative 2 billion. These numbers are abstracted with these lines of code. Integer values in Java are represented by values of type int, which are stored using a finite amount of memory. Therefore, an int value must be in the range from integer.minValue to integer.maxValue inclusive. Pretty self-explanatory. Because of the way integers are stored, any integer value you want to use has to be either the max value, min value, or anything in between. If an expression would evaluate to an int value outside of the allowed range, an integer overflow occurs. The result is an int value in the allowed range, but not necessarily the value expected. Let's say we set up a print statement to multiply the max integer value by 5. Because this number is about 10 billion and outside of the possible range, we are going to cause an integer overflow. However, when the code compiles and runs, it is not going to give us a runtime error, it just gives us a wrong answer. So if you're ever working with numbers in the billions in your code, for whatever reason, be mindful of integer overflows because it's possible you could have no idea when one happens. Computers allot a specified amount of memory to store data based on the data type. If an expression would evaluate to a double that is more precise than can be stored in the allotted amount of memory, a round-off error occurs. The result will be rounded to the representable value. To avoid rounding errors that naturally occur, use int values. Let's set up a print statement to output the value of 10 divided by 3, the value of 10 divided by 3 being 3.3 repeating. Because mathematically the evaluation is infinite, and the memory for a double is not, this results in a round-off error, with the last digit being a 5. The reason why this digit is a 5 and not a 3 has to do with how the number is stored in binary in the memory and really doesn't matter for the course at all, so don't worry about it. Similar to the integer overflow, when a round-off error occurs, the output does not tell you. So once again, just be mindful. And that brings topic 1.5 to a close.